For most of history, we thought our solar system ended with the gas giants, Jupiter, Saturn, Uranus, Neptune. Then, in 1930, Clyde Tombaugh discovered Pluto, a faint distant point of light at the edge of our cosmic neighborhood. For decades, Pluto was just a blurry speck, a frozen, silent world billions of miles from the sun. Our best telescopes showed only a pixelated sphere, smaller than our moon, colder than anywhere else we knew. We imagined Pluto as a dead world, geologically inert, its surface a static museum of cosmic history. It was the last outpost, a lonely wanderer in the Kuiper Belt, fitting neatly into our categories. Inner worlds were rocky, gas giants were stormy, and distant worlds were frozen relics. Pluto was the quiet kid in the back of the classroom, presumed unchanging and unremarkable. We had no reason to suspect it was hiding profound secrets. Science, though, is about challenging assumptions. We thought we knew Pluto, but we'd never seen it up close. All our knowledge came from faint light, like trying to describe a city from a blurry photo taken 100 miles away. We were about to get the shock of our scientific lives. The universe, it turns out, is always more creative, more complex, and far more surprising than we can imagine. Pluto was about to rewrite its own story. Our old map said, "Here be nothing but ice and silence." But science is a journey of revision. We had classified Pluto, measured it from afar, and written its biography as a simple frozen sphere, but we had never visited. We were about to discover how wrong we were. Pluto was waiting to surprise us all. Then came New Horizons, a spacecraft launched in 2006, racing for nearly a decade and 3 billion miles to reach Pluto. Its mission, fly past Pluto and give us our first close-up look. As it approached in 2015, the images stunned us. The blurry dot became a complex, vibrant world. We saw a giant, heart-shaped feature sprawled across its surface, a love letter from the outer solar system. High-resolution images revealed smooth plains, jagged mountains, deep chasms, and flowing glaciers of nitrogen ice. Pluto was not a dead, cratered relic, but a dynamic, geologically active world. Every new image deepened the mystery polygonal shapes in the ice, strange bladed terrains, and a surprisingly complex atmosphere with layers of haze. Pluto was alive, not with biology, but with powerful forces of geology and chemistry. The flyby lasted only hours, but the data would keep scientists busy for decades. Pluto transformed from a distant point of light into a real place, a world with weather, geology, and a dramatic history. The lonely wanderer became the star of the show. New Horizons didn't just rewrite textbooks, it opened a new chapter in planetary science. Pluto's story was just beginning. The universe had surprised us again. We realized how little we truly knew. Pluto was no longer a footnote, it was a cosmic puzzle box, and we were just starting to unlock its secrets. At the same Sputnik Planitia's location hints at something mind-boggling, a hidden ocean beneath Pluto's ice. The basin's mass suggests a dense liquid ocean sloshing below, kept warm by radioactive decay and insulated by thick ice. This ocean would be salty, dark, and high pressure. A hidden realm in the farthest reaches of our solar system. If it exists, it could explain Pluto's young surface and strange geology. On Earth, where there's water, there's life. Could the same be true for Pluto? The possibility of a subsurface ocean forces us to rethink where life might be found. The habitable zones of the universe may be hidden deep inside icy worlds. Beyond Sputnik Planitia, Pluto's landscape rises into colossal mountains, not of rock, but of water ice as hard as granite. These peaks, some over 11,000 feet high, float in seas of softer nitrogen and methane ice. The Hillary and Tenzing Montes rise dramatically, shaped by powerful tectonic forces. Some mountains are dusted with reddish tholins, organic molecules created by sunlight and cosmic rays. This alien weather paints Pluto's landscape in otherworldly hues. Pluto's mountains are monuments to the strange physics of the outer solar system. They challenge our Earth-centric ideas of what a mountain can be. Each peak is a clue to the powerful forces shaping this distant world. Pluto has an atmosphere, thin, mostly nitrogen, with traces of methane and carbon monoxide. As Pluto orbits the Sun, its atmosphere thickens and thins, sublimating and refreezing in a centuries-long cycle. New Horizons revealed a stunning blue haze, extending over 100 miles above the surface. These haze layers, made of tholins, suggest complex meteorology on a world with barely any air. The atmospheric cycle drives glacial flows and renews Sputnik Planitia. Even as Pluto moves away from the Sun, its atmosphere persists, defying our models. Pluto's thin, layered atmosphere is a bridge between surface and space, a laboratory for exotic chemistry. It's a ghostly breath in the deep cold, a sign of change and mystery at the edge of the solar system. Pluto's blue haze reminds us, this is no simple ice ball, but a world of subtle, complex interactions. Pluto's atmosphere is escaping into space, hundreds of tons lost every hour, far more than expected. Yet Sputnik Planitia remains full of nitrogen ice, presenting a paradox. How is Pluto replenishing what it loses? One theory: Pluto is venting gases from its interior. Cryovolcanism, resupplying the surface and atmosphere from a hidden ocean. Pluto isn't just geologically active, it's breathing its insides out into space. Each discovery leads to deeper questions. What erases the craters? What's the heat source? Could there be life? Pluto reminds us that the cosmos is stranger than we can imagine. The greatest discoveries are still out there, waiting in the dark. And Pluto, once a blurry speck, is now a beacon of cosmic mystery.